Assalamu alaikum. Today we are going to see the topic Fourier series. Okay. Subscribe my YouTube channel Explore Maths with Abdul Azim Sir. Share it with your friends and relatives. Now let us begin our topic Fourier series. Now just to see the brief introduction. In applied mathematics, a Fourier series is a way to represent wave-like single-valued function as the sum of simple sine waves. Okay. More formally, it decomposes any periodic function or periodic signal into sum of a possible infinite set of simple oscillating functions, namely sine and cosine. Fourier series is a very powerful tool to solve ordinary and partial differential equations. And the Fourier series has many applications in electrical engineering, vibration analysis, optics, signal processing, image processing, quantum mechanics, and etc. This is the brief introduction. Now let us see the definition. Periodic function. Periodic. So a function f of x is said to be periodic with t greater than 0 if it is defined for all real x and if there is some positive number t such that f of x plus t is equal to f of x for all x. Okay, this is the definition. So if the value of each ordinate means y value, ordinate f of x repeats itself at equal intervals in the abscissa x, then fx is said to be a periodic functions. Okay. So if f of x is equal to f of x plus t or f of x plus 2t and so on, then t is called period of a function f of x. Okay, this is the first definition. Now an example, sin x and cos x are periodic with period 2 pi. Tan x and cot x are periodic with period pi. Sec x and cosec x are also periodic function with period 2 pi. These are the example for periodic function. Now definition orthogonal function. So a set of continuous function phi of n x and where n is equal to 1, 2, 3 up to so on is said to be orthogonal in an interval a comma b if integration a to b phi of mx into phi of nx dx is equal to 0 for m not equal to 0, for m not equal to n, and not equal to 0 for m is equal to 0. Now this is very our topic, Fourier series. You must remember this definition. Okay, Fourier series. So f of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity bracket of an cos nx plus bn sin nx. This is known as Fourier series, where a naught bn and a naught an bn, where n is equal to 1 to n, are called Fourier coefficients of f of x. This is the formula you must remember. Now we have some useful integrals we should remember. These integral have useful in Fourier series. So first, integration c to c plus 2 pi sin x dx is equal to integration of sin x minus cos nx by n c to c plus 2i. So if we apply, you will get 0 where n not equal to 0. Next, integration c to c plus 2 pi cos nx dx, integration cos x sine nx by n c to c plus 2i. So that is equal to 0 where n not equal to 0. Next, integration c to c plus 2 pi sine square x dx. So first sine square dx, we have formula 1 minus cos 2 nx by 2. Okay, sine square nx. So here integration of 1 x cos nx sin nx, here by 2, 2 2s are 4. So if we apply, we will get pi. Next, integration c to c plus 2 pi cos square x dx. So c to c plus 2 pi. So cos square x 1 plus cos 2nx by 2. So integration of 1 x, integration of cos 2nx sin 2nx by 2, 2 2s are 4. If we apply the limit, we will get pi, n not equal to 0. Next formula is integration c to c plus 2 pi sin mx cos nx dx. So this is nothing but 1 by 2 c to c plus 2 pi. This I can write as 1 by 2 sin sum plus sin difference, sin m plus nx plus sin m minus n dx. So integration of sin 1 by 2 as it is, integration of sin minus cos m plus nx by m plus n minus integration of sin minus of cos m minus nx by m minus n, the interval c to c plus 2 pi. If we apply, we will get 0 where m not equal to n. Next, integration c to c plus 2 pi cos mx cos nx dx. So this I can write as 1 by 2 cos sum plus cos difference, yani cos m plus nx cos m minus x dx. So now 1 by 2 as it is, integration of cos m plus nx sin m plus nx by m plus n, and integration of cos plus as it is, integration of cos sin m plus n minus m minus nx by m minus n c to c plus 2 pi. If we apply, you will get 0. Next, integration c to c plus 2 pi sin mx sin nx dx. So this I can write as 1 by 2 cos m minus nx minus cos m plus n dx. Okay, now integration cos sin m minus nx by m minus n minus as it is, integration of cos x sin m plus nx by m plus n in c to c plus 2 pi. If we apply, we will get 0. So these are the integrals useful in Fourier series. Next thing also, Bernoulli's rule. So what is Bernoulli rules? We have already seen our previous video. Here the general, it is a general rule for integration by parts, general rule by integration by parts. So that is integration uv dx is equal to u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 up to so on. So where dashes denote the successive derivatives of u dash means first derivative, u double dash means second derivative, third derivative for u, and suffixes denote the successive integrals of v. So v1 means first integration, v2 means second integration, v3 means third integration, v4 like that. Okay. Now another formula, integration e power of ax sin bx dx. So we have a formula e power of ax by a square plus b square, a sin bx minus b cos bx. Next, integration e power of ax cos bx dx. So e power of ax by a square plus b square, a cos bx plus b sin bx. Next, some important formulas, sin n pi or sin 2n pi all 0, Similarly, cos n pi is equal to minus 1 of n, cos 2n pi is equal to 1. Sin 2n plus 1 into pi by 2 is equal to minus 1 power of n, cos 2n plus 1 pi by 2 equal to 0. Sin n pi by 2. So if n is odd, minus 1 power of n minus 1 by 2. If n is even, 0. Next, cos n pi by 2. If n is odd, it is 0. If n is even, minus 1 power of n by 2. Okay. Now next we will see very important topic, Euler's formula. Okay. So very important for examination point of view. So the Fourier series for the function f of x in the interval c x c less than or equal to x less than or equal to c plus 2 pi is given by this one. You must remember these formulas. F of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity a n cos nx plus sigma n is equal to 1 to infinity b n sin nx. Mark it as first equation, where a naught, this a naught value is 1 by pi integration c to c plus 2 pi f of x dx. an is equal to 1 by pi integration c to c plus 2 pi f of x cos nx dx. This bn value is 1 by pi integration c to c plus 2 pi f of x sin nx dx. Okay, remember all these formulae. This formula f of x, a naught value, an and bn. Examination, these are the very important thing you have to do. So now let us see the working rule to find these a naught, an, bn values. Mark it this as first equation, second, third, fourth. Now working rule to find a naught. So what we have to do, integrating both sides of equation first with respect to x, from x is equal to c to x is equal to c plus 2 pi, we get integration c to c plus 2 pi f of x dx is equal to a naught by 2 constant, take outside, c to c plus 2 pi dx plus take out in sigma n is equal to 1 to infinity outside. So an's integration c to c plus 2 pi cos n dx cos nx dx plus bn integration sin nx dx. A naught by 2 as it is, integration 1 x c to c plus 2 pi plus sigma n is equal to 1 to infinity cos nx infinity, already we have seen 0, this already we have seen 0. So 0 something 0, it will 0. Only thing is a naught by 2, if we apply this, we get a naught. So this left side is this one, right side is this one. So send this that side, it become a naught equal to 1 by pi c integration c to c plus 2 pi f of x dx. So this is the rule to find the a naught value. Now working rule to find an. What we have to do, again integrating both sides of equation 1 by cos mx and integrating from x is equal to c to x is equal to c plus 2 pi, we get integration c to c plus 2 pi f of x cos mx dx is equal to a naught by 2 integration c to c plus 2 pi cos mx dx plus integration n is sigma n is equal to 1 to infinity an bracket of integration c to c plus 2 pi cos nx cos mx dx plus in sigma n is equal to 1 to infinity bn, okay, integration c to c plus 2 pi sin mx cos mx dx. Here we are multiplying with cos mx, okay. So what we will get, left side as it is, a naught by 2 becomes 0, an. So this part, when both m and n are equal, so it become cos nx cos square nx dx, and this value becomes 0 as we have seen earlier. So the when we apply this, we will get pi only. So the an value is left side, send that side, it become an is equal to 1 by pi integration c to c plus 2 pi f of x cos nx dx. This is our an value. Now working rule to find bn. So what we have to do, multiply both side of equation 1 by sin mx and then integrate. Okay, from x is equal to c to x is equal to c plus 2 pi, we will get integration c to c plus 2 pi f of x sin mx dx is equal to a naught by 2 integration c to c plus 2 pi sin mx dx plus integration sigma n is equal to 1 to infinity an integration c to c plus 2 pi cos nx sin mx dx plus sigma n is equal to 1 to infinity bn integration c to c plus 2 pi sin nx sin mx dx. So this value becomes 0 as mx we have seen 0, cos mx cos nx we have seen 0, plus bn integration c to c plus 2 pi, it becomes sin square x. So when we apply this limit, we will get only pi as we have seen. So now send this pi that side, it become now bn value is 1 by pi integration c to c plus 2 pi f of x sin nx dx for n is equal to 1 to 3 and so on. So these are the working rule to find an, bn and a naught. As we have seen a naught, an, bn value for c to c plus 2 pi. Now note, if c is equal to 0, then in the interval of 0 less than or equal to x less than or equal to 2 pi of Fourier series will become a naught value become a naught is equal to 1 by pi integration 0 to 2 pi f of x dx. An value 1 by pi integration 0 to 2 pi f of x cos nx dx. Bn is equal to 1 by pi integration 0 to 2 pi f of x sin nx dx. If c is equal to minus pi for the Fourier series in minus pi less than equal to x less than equal to pi, then a naught value is 1 by pi integration minus pi to pi f of x dx. An value 1 by pi integration minus pi to pi f of x cos nx dx, and bn value is 1 by pi integration minus pi to plus pi f of x cos nx dx. These are the working rule. Now convergence of Fourier series. So the Fourier series of f of x converges to f of x to all points where f of x is continuous. Thus, if f of x is continuous at x is equal to x naught, the sum of Fourier series when x is equal to x naught is f of x naught. Okay. Now this is very important question. Conditions for Dirichlet conditions for Fourier series expansion. It will ask you. So remember these conditions. First, f of x is well defined and single valued except possibly at a finite number of points. This is the first condition. Next, f of x has only a finite number of discontinuities. Third, f of x has only a finite number of maxima and minima. So this topic concludes here. Before leaving, once again subscribe my YouTube channel Explore Maths with Abdul Azim Sir. Share it with your friends and relatives. That's all.